I'm pretty good at that, but she gave me...
I can give you a lot of help on the unit circle.
Okay, that's good.
So much help, then I'm reluctant to let you go by it without me doing anything. Let me check. What's the sine of 150 degrees?
Ooh. I don't know. I have to have it drawn out with me.
Okay. Are you in nothing but trig now, or are they just... I know you don't get a lot of trig in Algebra 2.
Yeah, well, right now, she just gave us the unit circle.
Okay. Well, I'm not sure. In a half an hour, I can barely give you the entire unit circle such that you can answer any trig function for any angle that's a multiple of 30 or 45 or... Okay, and that's the key thing you want to be able to do. You want to always know. The most, let me point out this, that for trig, these two basic triangles are huge. I mean,
the 36
they've been huge for 2 years with you, but they're even bigger when you get to trig.
Right.
Because this is the way you're going to figure out all of these common angles, is by referring to these two triangles. Okay? And as long as you know so, ka, toa, then you can figure out that the sine of 30 degrees is 1/2, right? Anna? You seem to have lost the audio. Did you somehow mute your microphone, perhaps, accidentally? I don't know if you can hear me or not. I cannot hear you. Now it says you went offline. I'll call.
Hi, I'm sorry, my computer died. So
I could tell. It said on my end that you went offline, and the only thing you can do is to reboot it, or if you're back in action, you can close out the GoToMeeting and then re-enter it.
Okay.
Okay, but if you have to reboot, yeah, I won't change the number.
Okay.
And so I'll just wait for you to get back online.
Okay.
Okay?
Sounds good.
All right. Talk to you in a bit.
All right. Okay, bye.
Bye-bye. Anna? Ah, you there? You're going to have to unmute your microphone at the top left of the GoToMeeting panel. Oh. Yes. Okay, you must be back now.
Yes.
Okay. Do you know what happens when that happens? Does your computer just shut down, or?
Yeah, if I don't have it plugged in, it's weird. It like sometimes will shut off if I don't have it plugged in. Like even if there's battery, but.
Okay. So it might just be a hardware glitch.
Yeah, maybe.
Right. I'm not sure how much you heard of what I was saying because I knew I lost audio, but I don't always know right away. I've been known to speak on for 5 minutes and the person lost audio the whole time. I don't know that we necessarily want to cover trig the whole session tonight. You probably have a test coming up before spring break. So
yeah, so I've got other things to cover.
I'll let you dictate what you want to cover tonight. But just with trig, between SOHCAHTOA and those two triangles, you can do all of the first quadrant angles.
Yeah.
Then it's just a question of figuring out how to make the second, third, and fourth quadrant angles what their equivalent first quadrant angle is. Then you can do all of the angles. Okay? But let me not direct the meeting here. Let's have you do it. You go ahead and verbalize problems that you want to cover.
Okay, well the first couple ones are supposed to be pretty easy, but it's 81 to the 1/4, and it says to evaluate the expression.
Okay. What's to the 1/4 mean?
To
the fourth root.
To what?
The fourth root.
Oh, okay.
In other words,
right.
If I have the square root, I can write that as 81 to the 1/2.
Okay.
But if I have the fourth root, where I would have a 4 there, I can write that as 81 to the 1/4. Whenever you have a fractional exponent, the denominator is the root.
Right.
If I said 81 to the 3/2, like that, well, what I would do is take the square root of 81, which is 9, and then I would cube 9. So that's how I would evaluate that. But what is the fourth root of 81?
Would it be 3?
Yeah, and always know that these are going to be small whole numbers. First of all, they're not letting you use your calculator, right?
Right.
Which means that the answer can't possibly be 3 1/4 or 3 1/2 or 2.7.
Right.
Because there's no way you could come up with that answer. But so when they give you a problem like this, know that your answer is going to be 2, 3, or 4. That's pretty much it. Just keep that in mind, okay? I mean, occasionally it might be 5. If I gave you this problem, what's the cube root of 125? Well, that's 5. Because 5 times 5 times 5 is 125.
Right.
All right, what else you got?
So, in parentheses, it's 5 square root 32, parentheses, -2. or to the power of -2, yeah.
Okay. So let's rewrite what's in the parentheses. 5 times the square root of 32. Well, I could write that like that. And now I can apply my rules of exponents.
Okay.
Well, this -2 applies to the 5, and it also applies to this. So apply it separately. In other words, that's the same as 5 to the -2 times what? If I multiply those two exponents, what do I get?
-2. Would it be -1?
Huh? So there's what it turns into. Now we need to do a little simplification. What's 5 to the -2 equal to? What number? What fraction?
I just
That's
know that it probably
5 squared. Don't let negative exponents mess you up. They're really easy. They don't mean negative numbers. They have nothing to do with negative numbers. What they mean is reciprocal. So when I write 5 to the -2, it's the same as 1 over 5 to the +2.
Okay.
And I can write 32 to the -1 as 1 over 32. So now I got 1 over 25 times 1 over 32. Well, whatever 25 times 32 is, which I believe is 800, that's the answer.
Okay.
1 over 800.
Cool. All right, the next one is find the inverse of the function f of x equals 3x minus 2 over 4.
All right. When you're dealing with inverses, the easiest thing is instead of using the f of x notation, use the y notation for starters. They mean the same thing. It's just that the rules for figuring out inverses are, there's two of them, switch the variables and solve for y. So if I'm using f of x notation, there is no y. So that's why the very first thing I do is replace the f of x with y. Now, first step, switch the variables. With me?
Yep.
Now solve for y. What's the way to solve for y? It's the first step.
Would you divide both sides by 4?
Multiply both sides by 4.
Or, yeah, that's what I mean.
The 4 is currently a divisor. And you're always going to do the opposite of what that, if I want to get rid of the 4, then I need to multiply.
Right.
Okay, so you're always doing the opposite. And if I multiply over there, I get 4x. So now I got 4x equal 3y minus 2. What's the next step?
Do you add 2 to both sides?
So now I got 4x plus 2. In other words, I'm trying to solve for y. And so I got to get rid of anything that's near y, being added to y, being subtracted from y, multiplying y, anything that's affecting y, I got to get rid of it.
So divide both sides by 3.
And there's your answer. Y equals this, and that is the inverse function of what we started with.
Okay.
They're not the same y's. In fact,
right.
Probably correct to put a -1 there, meaning that's the inverse y. And they would do it this way. They would say that's the inverse of f of x.
Okay.
Okay? And they would label it that way.
Okay.
All right, what else?
Okay, it says to simplify, and the question is parentheses x to the 2/3, and then parentheses to the power of 5/6.
Okay? What do we do when we have double exponentiation going on? That's what I call this. Double exponentiation.
Add that, I think.
Multiply the exponent.
Oh.
You're always going to do one level less. Remember this. If I am multiplying the bases, then I am adding the exponents. Right?
Right.
Addition is one level less than multiplication. If I am dividing the bases, I am subtracting the exponents, because subtraction is one level less than division. Well, when we're doing exponentiation, what one level less than exponentiation is multiplication. So the base stays the same, x. Multiplying the exponents, you get 10 over 18, which simplifies to 5 over 9.
Okay.
So it's x to the 5/9. But these three rules, remember those three rules, that'll take you a long way. It's the rules not only of exponents, but it's the rules of logs also. Logs work the same way.
Okay.
The log of AB is the log of A plus the log of B. In other words, my argument was multiplication, and I turn it into addition. All right, what else?
Let's see what else I okay. It says solve each equation, and it's 1/7 parentheses x plus 9 parentheses to the power of 3/2 equals 49.
What's the first thing to do?
Probably distribute the...
No, you can't do that, because what's inside the parentheses is being taken to this power. So you can never distribute first. The 3/2 power is not operating on the 1/7. It's only operating on what's in the parentheses.
Okay.
So the first thing I want to do is get rid of that 1/7. How do I do that?
So you divide both sides by 1/7?
Well, multiply both sides by 7. In other words, there's two ways to look at it. Sure, I can divide both sides by 1/7, but that's complicated. That is the same as multiplying by 7, incidentally. The easier way to look at it is just multiply both sides by 7.
Okay.
Okay? In other words, the reason is that the 7 is a divisor right now. So we want to multiply. That way that will cancel out, and we'll be left with x plus 9. Now that's still to the 3/2, and it's equal to 343. Now, the next thing I want to get rid of is that, which is operating on both the x and the plus 9. What do I have to do to both sides to get rid of that 3/2?
I want to say square root it.
Do it to the reciprocal.
Oh.
You see why I want to take it to an exponent that is the reciprocal of the one I'm looking at?
Yeah, so it'll cancel out.
Multiply these, and they're going to turn out to be 1, always. As long as I take it to an exponential that's the reciprocal of this exponential, then when I multiply them together, I always get 1. So the left side turns into just that.
Okay.
Now, the right side, I'm going to take the cube root first, Then I'm going to square my answer. Well, the cube root of this number happens to be 7. And how do I know that? Well, look at that number right there. That is 7 times 7 times 7, right?
Okay.
And that is what produced my 343. So therefore, the cube root of my number has to be 7. So
Right.
that's equal to 7 squared equals 49. So 343 to the 2/3 power is 49.
Okay.
Finally, subtract 9 from both sides. Solving equations is always about getting rid of everything that's attached to your variable. In other words,
Right.
the moment I see that equation, I know that I've got to get rid of the 1/7, I got to get rid of the 3/2, and I got to get rid of the 9. And in that order. I can't really take both sides to the 2/3 power without getting rid of the 1/7 because I would have to take 1/7 also to the 2/3 power. And that's some weird number. So that's not a nice simple number. So it's very important to get rid of the 1/7 first.
Okay.
What else?
Let's see. Oh, write an equation for a square root function with domain of bracket -2, comma, infinity, parenthesis, and a range of parenthesis, -infinity, comma, 1, bracket.
Write a function that has that domain and this range.
Yep. A square root function.
Okay, well, let's look at square root functions. There's the square root function, but that doesn't have that domain. However, what if I did this? Now, what's the domain of that?
The domain of...
Can x be -2?
Wait, sorry, what?
In other words, if this is the answer, does that satisfy my domain restriction?
Yeah, because it's just talking about...
Exactly.
Oh, okay.
In other words, the way I solve for the domain of this is I said x plus 2 has to be greater than or equal to 0, which means x has to be greater than or equal to -2, which is the domain you gave me.
Okay.
Okay? So that function satisfies the domain. Now, unfortunately, this function has a range of all positive numbers only, not negative numbers, and certainly not to 1. So how are we going to do that? Let me think for a minute. A square root function how about now my domain I've actually changed a little bit, but ignore that for the moment. Would this function have the proper range? Well, the lowest value for x is -2. Anything above -2 is going to produce a positive, so let's put a negative sign in front of that. And now, notice, no, it never goes to -infinity. And when x is -2, that doesn't work. Oh, that doesn't work. Not to mention, when I put that in the denominator, it actually changes the domain. In other words, x can no longer be equal to -2 because that's going to cause division by 0.
Okay.
So let's go back and look at this. Now the question is, how do we get this range is y greater than or equal to 0, as opposed to the range you gave me? How do I get the range to be 1? Well, what if I add a 1 like that and put a negative sign in front of that? Now, notice that I did not affect my domain. My domain, I still have to say x plus 2 has to be greater than or equal to 0, which gives me this domain up here. And my range, notice that I can get to negative infinity by just making x get very large. Because as x approaches positive infinity, then that approaches negative infinity. And if x is exactly -2, then y is going to be 1. So there's my equation. In other words, that equation satisfies my domain and my range.
So the +1 is not going to affect the domain?
No, the domain is only affected by the fact that you cannot take the square root of negative numbers.
Okay.
The only thing that affects my domain is this part here. However, the +1 does affect the range because, in other words, this can obviously be 0 if x were -2, and then +1 gets me to +1. So I can always make y equal to +1. But notice that with this function, I can never make y greater than 1, because that would require that that be some positive number. And that can never be a positive number. In other words, the result of that is always a positive number, but then I got the negative sign in front of it. So it's impossible for negative square root of x plus 2 to be a positive number. However, it can be a negative number that approaches negative infinity. Because all I have to do is let x approach positive infinity, and this whole thing approaches negative infinity, which means the entire range approaches negative infinity. So I get that part by just letting x go to positive infinity. And if I let x be -2, then y gets all the way to +1. But it can never get more than +1.
Okay.
That's kind of an interesting problem. I don't see many problems structured quite like that, where they give you the domain range and want you to come up with a function for it.
Yeah.
It's after 9, but we missed like 10 minutes while you were logged off. If you want, I'd be happy to go over a little bit if you've got some more problems you want to cover.
Okay, I just have one more question.
Okay.
And it says expand the expression, and it's another one of those log ones, but it's log base 4, and then x to the second, and then y to the third over z to the 7th.
Take it one step at a time. So I'm going to separate the multiplication into 2 additions, and I'm going to make the division a subtraction.
Okay.
Remember, the log of a times b is the log of a plus the log of b. And the log of a divided by b is the log of a minus the log of b. So basically, this is going to turn into the log of x squared plus the log of y cubed minus the log of z to the 7th. That's the first step of expanding. Still not totally expanded, because 1/3 rule that you can do is if the argument has an exponent, you can bring that exponent and put it in front like that. So each of these exponents I can do that to. And what that gives me is 2 log base 4 of x plus 3 log base 4 of y minus 7 log base 4 of z. Make sure you understand every step I did there.
So you just added the x and the y and the z to it?
Well, I added them because they were being multiplied. And then I subtracted the log of z because z is a divider.
Right.
So when you have multiplication, you're adding 2 different logs, and when you have division, you're subtracting. And then you can always use this rule, the log of a to the b power equals b times the log of a. In other words, that's the 3rd rule I used in order to bring all these exponents down on the algebra line in front of the log.
Okay.
Okay? And on these, make sure you can go both ways. In other words, they're going to give you an equal number of problems that you have to expand as condense. In other words, the next problem they might give you is they give you this and they say condense it. Well, you're just going to go through the exact reverse. First condense it gets me back to that line. Second condense gets me back to that.
Okay.
Okay? And it's really only those 3 log rules that you have to pay attention to. Is what happens when there's multiplication going on in the argument, add 2 separate logs, and if you have division going on, you're going to subtract out that log of that.
All right.
Okay?
Well, that's really all I have tonight.
Okay. That's fine. So I will cancel next Tuesday's 8 o'clock session.
Okay, that sounds good.
I will plan on seeing you a week from Tuesday at 8.
Okay.
Okay? And if you need to change it, just let me know. Always happy to do that. Anna, have a good spring break.
Thank you.
You're welcome. I'll talk to you in a week or so.
Okay, bye.